We'll just do this. Let's look at this example here. X with, whoa! So the example again. If we had x to the 5th power raised to the 18th, whoa! All right, algebra, we're going to look at power of a power, the power of a power exponent rule. And it goes something like this. Imagine I gave you x squared to the 3rd power. Okay. Well, something raised to the 3rd power means that I'm going to multiply it times itself 3 times. So x squared to the 3rd power means x squared times x squared times x squared. And each one of these x squareds means that I'm multiplying itself by itself twice. So we have x times x times x times x times x times x. So this x squared is represented here. This x squared means x times x, and this x squared means x times x. Well, that's, let's see how many x's that is now. 1, 2, 3, 4, 5, 6 x's. I'm sorry, x times x times x times x times x times x 6 times means x to the 6th power. Well, there's got to be an easier way of doing this. In fact, if I had just taken 2 times 3, I would have gotten this x to the 6th power. So that's going to be the easier way of doing this. Thinking more abstractly, if we have a, let's do this example here, a to the m raised to the n power, which is similar to this example here, that's a to the m times n power. This is the rule, the exponent rule for power of a power. Let's look at one more example. Something like x to the 5th raised to the 3rd power. Well, I don't want to write this all out like I did here, otherwise known as expanding it. I don't want to expand it like that. It's going to take too much time. I can just say, oh, well, 5 times 3, if I just multiply these exponents, that's 15, so this must be x to the 15th power. It's a lot shorter. Let's look at just one more example. Something like x to the, let's switch it up. Y to the 12th power raised to the 5th power. Well, that's just y to the 12 times 5 power, which is y to the 60th power. And that's your answer. Get it?